If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in basic level where we are building concepts on functions. So in continuation we will start from dependent and independent variable, then what do you mean by even and odd function, then periodic function, and then representation, and then composite function. Okay, then let's see this. Now next come to what is dependent and independent variable. Suppose y is a function of x, then the value of y depends on the value of x. The value of y depends on x, while x is nothing but input. Because you can see whatever input you give x input, then you use the relation to find y. So y is not giving values independently. Independently who is taking? X is taking arbitrarily any value. You apply on function, you get out. So x is independent, but y is depending on x. Whatever x you are selecting, based on that y will come. So that's why y depends on x, which is input. So y is known as the dependent variable and x is independent. So this is the machine where you are putting this input x and you are getting this output. So it is depending on whatever input you are giving. So what is even function and odd function? Having known about function, so we know f is suppose a real valued function f. No, we have already started what is real valued function. Now if you change the values of x to minus x, suppose there is no change in the function for all x in the domain, whatever domain you have selected for that function, for every x if you change it in direction plus to minus, suppose there is a plus 5, you take it minus 5, then also it is connected to same y, that means output is not changing, then it is known as even function. One example is fx equal to x square plus 2. Now if you put minus x also, it will still remain x square plus 2, original function. Suppose if you put 2, then output is 4 plus 2 6. If you put minus 2 also, then also output is 6. For 3, the output is 9 plus 11. For minus 3 also it is 11. For every x in the domain, the output remains same. Your domain is any real number. You took any real number, you put it minus, your output will remain same. So this is known as even function. So this is the definition of even function algebraically. Now graphically, how does it look like? Graphically, even function will look like a even function. You can think of this is nothing but a parabola we have studied. So this is a smiling parabola. It is shifted word of this fashion. So this is the graph we say. This is x-axis input and this is your output y. You give input, you take output. So here you can say if you put 2, so your output is 6. If you put 2, then your output, this height is 6. If you put minus 2 also, then also your height is 6. So you can see it is symmetrical about y-axis. Whatever you put it here, the same thing you can put left side also. Whatever you are putting right side, for that you have a point in right side which is giving same value. So it is symmetrical about its y-axis. So whatever positive x you give, for same value of x, you change the sign, you will get same height. So you can see the both for here also. So for some x you are getting this same, for same x with the minus sign you will get same height. So this is known as even function, which is symmetrical about y-axis. You can recall your cos x. In trigonometry you have studied. This is your cos x function. You can see it is symmetrical about y-axis. You take a mirror at y-axis, or you fold your page in y-axis. You will feel this graph is coming just above this one. My drawing is not perfect, but it should come. This will come just align. This will align above this one. Cos x also, this is even function because cos minus x is cos x. And you can see for this side it is pi by 2 it is 0, so minus pi by 2 also it is 0. 3 pi by 2 minus 2 minus, sorry, pi is minus 1, so minus pi is also minus 1. Now what is odd function then? Same notion. If f minus x is now, it is not fx, it is cannot, here or even function can digest this x. You can see it, if you give x, it is digesting, it is not coming out. But odd function it cannot digest. If you give minus as input, it will give output also as a minus. So it cannot digest that minus. So it is known as for all x in the domain. It should not be. It should be for all x in the domain. It should not be for 1 and 2 cases only. Then it is known as odd function. Suppose fx equal to 5x or y equal to 5x. Y is the output. So if you put minus x now in place of x, so it will be minus 5x. So it is minus fx. Not original fx was 5x. So it is an odd function. So graphically you see it is y equal to fx. If you put y equal to 1, your output is 5. If you put y equal to minus 1, then your output is minus 5. So output is changing. So it is the reflection on this point has a reflection here. This is the reflection on the point origin. This is reflection on line. This is reflection on a point. So it is graphically odd function is symmetrical about its origin. You can think of your sin x. So it is for each point you will find a point. You take a reflection on this origin, you will find another point. For this point, you take a reflection this point, you will find a point. So it is reflection about origin. So it is symmetrical. Odd function is symmetrical about its origin, not that line. Now next is periodic function. What is periodic function? Suppose fx is a real valued function. So f is said to be periodic function if there exists a positive number t such that after that number, after you cross that limit, the same output is repeating. So fx plus t, whatever you got this output until now, after t you are repeating that same output. Your output is not changing. So it is the same output which is repeating after a particular interval for all x in its domain, then it is known as periodic function. The smallest possible number, it can be repeating after this much, after this much, after this much. The smallest number after which it is repeating, the smallest block you can take, which is unique, and after that the same block is repeating, that is known as period of that function. So some of the good examples of periodic functions are your trigonometric functions, best examples. So suppose you take sin x, so you can see your sin x is repeating after every 2 pi. So if you take this block, it is the same block. It is repeating after 4 pi also. If you take this block, the same block is putting here. You can put it there. You cut it, paste it there, it will be same answer. Because sin 90, you can see if you take this number, this is 1. If you move 2 pi value, you add from here 360, you will find here you get the same number. You add 4 pi here, you also get the same number. So the same number 1 is repeating after every 360 or 720. Or you can take others also. But out of that, the smallest one is 360. After 360, that is after 2 pi. After 2 pi it is repeating. After 4 pi also it is repeating. But the smallest out of that is 2 pi. After 2 pi you can say it is repeating. So this is the smallest unique block that you can take, and rest is just copy paste, copy paste. So best examples are this one. So sin x plus 2 pi is sin x. Sin x plus 4 pi is also sin x. But 2 pi is the smallest one, so that's why period of sin x is 2 pi. We have discussed all these periods in trigonometric function. You can refer that one. Now in how many ways we can represent a real valued function? So there are different ways. One is numerical representation by tabular values. So you put all these values which are connected to x and y. So you pull all these values and you see this one is connected to, this one is connected to, this one is connected to. That is tabular format. This is visualization, that if you draw a graph, so you can say, okay, this x1 is connected to this one, this x is connected to this y, this x is connected to this y. This is known as visual representation of graphical. Last one is analytical. So both this representation will give you some idea how it is connected, but they will not give you the exact formula by which it is connected. Then they will not give you any expression, analytical expression, or any prescribed formula, prescribed rule by which it is connected. They will give you idea that it is connected, but not that exact rule. But explicit formula or rule will not be given in these two expressions. But this analytical will give you exact formula like this. So there is an exact formula between x and y. If you put x, give x, then you take this expression, find out if you put x equal to 1, calculate it, you will get the corresponding y. So from that you can form that table also, from that you can plot that graph also. So using analytical expression, these two can be formed. But using these two, this cannot be formed. Okay. So generally this is the format that we generally give, and we draw the curve, we find out the points which is there from that analytical expression, which is also known as closed form. Now next is composite function. So I have given you just brief intro here. In advanced portion we will learn it in details more. For basic it is okay. F and g are two functions, then the composite of this f and g are defined as fog or GOF, FOG. FOG of x is f of g of x. So function over function. So or another one is known as GOF. One is fog, one other GOF of function is g of f of x. So two types of composition is possible. Suppose fx is x cube, gx is. So this is back to back machine. One machine, then another machine. If you do two mixer machine, first you do first step of mixing, then you do second step of mixing. So two machines are there. You can think of it as a brick machine, a brick breaking machine, and this is a mixer machine where you mix or you bricks, sand, and then cement, all that. So first you brick, whatever output you come, you take that one to the mixer machine, then you mix it out, then you got that item for your work. Suppose your fx is x cube, gx is. So what is f of gx? So in place of gx you put 10x, that is f of 10x. So what is 10x? What is the purpose of f? Whatever input you give, it just cube it. So here input is 10x, so you will cube it. So 10x cube. So output is 10 cube x. What is GOF? G of f of x. So g of f of x is x cube. So what is the purpose of g? Whatever input you get, it take tangent of that one. So it will take tangent of x cube. So 10x cube. So these two obviously are not equal. So fog and GOF are not equal. It is something like that. Fog, something like that. First f will eat. This is g of f of x actually, not fog. Just correct it. G is taking the f as output, and here it is. So whatever first f will eat, whatever output f will give, g will eat that one, and finally g will give this output off. Here first g will eat, whatever output g will get, f will take that one, and f will give output as a fog. You correct all these things in the notes. If you like the video, then press the like button and please give your valuable comments in the comment section.